In this video, I'm going to demonstrate how you can conduct analysis of variance test using R. As you recall from the video on t-test, the t-test can only compare two groups. So in order to compare more than two groups, we need to use a one-way analysis of variance. Again, as with the t-test, the groups have to be independent of each other. So as in the example of, say, we want to test whether or not there's differences in length of stay between different types of marital status, patients with different types of marital status, such as married, single, divorced, and widowed. The null hypothesis would be that regardless of the type of marital status, patients have the same or equal length of stay. Okay. So let's go ahead and test that using the Hospital 1 dataset, which has the Hospital 1. Hospital 1 has marital status and length of stay. So let's click on File, Open File, and my Hospital 1 is on my desktop as usual, and I'll double click Hospital 1.r data. Here it is. I'm going to click on it and we get our spreadsheet. Alright, so before we go on, there's one thing to keep in mind, is that R doesn't really give us the means when we calculate the analysis of variance between groups, that is, the means between groups. So let's use the psych function, the psych package, and the function described by in the psych package to display the various means between different types of marital status. So I'm going to go ahead and I'm going to open up the psych package, or load it. And now we're ready to use the describe by function. So if you don't have it installed, stop the video, go ahead and install it, and load the package like I just demonstrated. Okay, so I'm going to type in describe by, and I'm going to put in the dependent variable first, which is length of stay. So it's Hospital 1, as we usually do, $, and now we're going to put in the length of stay, and just a comma, and Hospital 1, $, and then marital status, which is our grouping variable, and hit enter. So we get the various means. So you could see that single and divorced patients have the highest length of stay. Married and widowed have the lowest length of stay. So married folks have a 12-day length of stay as compared to those who are single with 39 days on average. So let's go ahead and do our analysis of variance. So with the analysis of variance, we need to store our findings in a vector, which is like a file cabinet. So what is a vector? A vector is kind of like a variable, like I said, that's a file cabinet that any information produced in R can be saved to. So if I'm going to create one called M1, that is a vector called M1. So I'm going to type in M1, followed by a less than sign and a dash. And now I'll put in the command of AOV, and I'm going to start by typing in my dependent variable, just like with the t-test, hospital 1, and $, and length stay, and then again that tilde, which is shift and the key underneath the escape key, and then hospital 1. I'll use the fly out, it's safer, and then $, and then marital, and that's all I have to do. So I could tell it's correct because it put the listed vector up here and it didn't give me any error. So I'm going to type in the summary command, and we could use summary AOV, and oops, let's do that again. Let's use the summary AOV, and I'm going to type in the vector model 1, which will now print out, M1, which will now print out, so remember it's M1, which will print out our findings. So you can see that here we have a significant difference, but it only tells us that the model is significant. We don't know where the differences really are. We know that there is a difference, but we don't know where. In the t-test, when we compared gender, or in the case of spouse, we could see where the differences were, which that people who were living with the spouse had a lower length of stay. Here we can compare single to married, single to widow, single to divorce, married to widowed, married to divorced, etc. So we need to take an extra step by using something called the Tukey HD, which is a post hoc test, which will show us exactly where the differences lie between the groups. So we'll type in Tukey. There it is, Tukey HSD. It starts with a capital T, HSD, and then our vector M1. That's the other reason why it's a good idea to store it in a vector. So now I'm going to hit enter, and you notice it gives us married versus single, and then it gives us the p-values. So the two significant differences are married and single, and widowed and single. But keep in mind that I believe the divorce group only has 4 patients in it. Okay, so that normally you'd want to have at least 10 or more in a group, but we're just using this as an example. So you could see that this is where the differences are. It's between those married and single, okay, which had the highest length of stay. So that concludes the analysis of variance example, and so hopefully you would be able to replicate this by using length of stay again, if you'd like, comparing the various age categories, the variable age cat. Give it a shot.